Hello and welcome to this refresher on kinematics for Physics 190. My name is Matthew Woods. I am Assistant Director at the Academic Support Center here at the College of St. Rose, and I'm in charge of our fledgling Math and Science Learning Center. For this workshop, the only thing that you'll need besides something to write with and a calculator is the student packet, which you can find on the College of St. Rose website, which the link will be provided for you on the video description. And I ask that you please just print that out and fill it in as we go along. Now, before we begin, let me just say that if you have a question at any point during this refresher that, oh, this isn't making sense, or can you please explain this, and since I'm not actually with you at that time, you feel free to send me an email. Just please put the name of the workshop in the title, in the subject heading, so I know what we're talking about. There will be a couple points during this presentation where I ask you to pause the video and do workout for an answer for practice. So just keep that in mind as we go along, that you're going to have to pause at some point. With that said, let's begin. Now, what do you need for these problems? Well, you'll need a calculator, and you'll need a calculator that can handle trig. So it can do sine, can do cosine, can do tangent, can do the inverse of those. So you need one that can do sine, cosine, tangent, basically. Pen, pencil, obviously you need something to write with. I would prefer pencil because if you make a mistake, then you can go back and correct it a lot easier than a pen. And you need your formula sheet. So you need to know what formulas you're going to use. You should have gotten from the professor a sheet with all the formulas for the semester. And you'll need that to keep referring to. But I will let you know what formulas we're using. We're only using a few. Some general tips for physics. I like to remind people of these throughout the year. These are things that I found helpful when I was a student here many moons ago, things that helped me learn physics and excel in physics. So these are 6 things that you should know and should try to do. We're going to start actually with this one down here, the difference between vectorial and magnitudinal. So, vector means quantity and direction. Basically, that means that not only how much is there, but where it's directed. So 30 meters north versus just 30 meters. Magnitude is just the quantity. So 30 meters for how far you've moved, that's a magnitude. If you've gone 30 meters north, that's a vector. All right, so what about each of those 5? Well, let's think about it for a minute. Speed means magnitude. All right, speed is just how fast you're going. If a cop pulls you over, he's not going to ask you for, which direction you were going. He's just going to ask you how fast. Velocity is how fast in what direction. All right, velocity is a vector. Easy to remember, VV. Distance is a magnitude. Distance is only how far you've moved from the center or from your starting point. Doesn't matter the direction. Displacement, it does matter the direction. Displacement is a vector. Right. And acceleration means how much your velocity is changing. Usually it's going to be a vector. All right, because usually acceleration is based off of velocity. So acceleration is a vector. Formulas needed for kinematics. All these are for use in one dimension only. You can't do x and y at the same time. We have constant acceleration for each of these. And the key to all kinematics problems is just to know which formulas to use when. And that depends on what they give you. So here they are. Formula A, Vf equals Vi plus At. And this F means final velocity. This I means initial velocity. D equals VIT plus 1/2 AT squared. And C, VF squared equals VI squared plus 2AD. Now, I'm going to be referring to these off and on throughout the presentation. So I would recommend, starring this page, starring the slide. We're going to keep referring back to these because we need to use all 3 of them. So we're going to begin with just one-dimensional motion, just basic, moving in one straight line. Car is traveling at 30 meters per second. It approaches a light that has turned red and skid to a halt. It slows down at a constant rate of 8 meters per second squared. So that's what this m slash s slash s is, meters per second squared. Assuming no friction, how far will the car skid before it stops? All right, so the first thing that you're going to do is you're going to draw it out. Now I'm going to use the whiteboard behind me. I just hope that you can see everything that's going to be on there. If you can't, I apologize. The camera on the computer is not that great. If you can't, send me an email, see if I can do something else to help you out. But I'm going to draw it out. Now, I'm not going to draw it big, fancy, a full-blown car. I'm just going to draw a little box. So here's my car. All right, and it's going 30 meters per second. And it doesn't necessarily say which direction, so I'm just going to say moving to the left there, or my right, I guess. And it's going to slow down at a rate of 8 meters per second squared. So its acceleration's the backwards direction, and that's 8 meters per second squared. And this is VI. Okay. Assuming no friction, how far will the car skid before it stops? Okay, so I've got my diagram, it's labeled. Now underneath I'm going to create a list of my variables. So I know I've got VI, that's 30 meters per second. I've got A, which is negative 8 meters per second squared. Now why is it negative? Well, the car is moving in that direction, so that way is positive. Acceleration is acting in that direction, so it's directly opposed to the direction of motion. That's going to make it negative. VF, I know, is 0 meters per second. How do I know VF? Well, it says in the problem that it's going to skid to a stop. And stop obviously means it's not moving. And I'm looking for the distance, so that's my x. So which formula am I going to use? Well, let's see. I want one with VF, VI, A, and D. I don't have time, so if time is in the formula, I can't use it. So that leaves just one choice. And that is VF squared equals VI squared plus 2AD. VF squared I know is 0. VI squared, VI is 30 squared plus 2 times negative 8 times x. So 0 equals 900 minus 16x. 16x equals 900. X equals, you should get 56.3 meters. You will get on your calculator 56.25. You can round it to 56.3. But let's check units here. We're going to do some dimensional analysis. VF squared, that's meters per second, and that's squared, equals meters per second squared plus meters per second squared, like that, times meters. Well, does that actually work out? Well, if I bring this over here, I've got meters per second squared equals meters per second times meters. This will cancel out with the seconds. One of these meters will be left. It works out. Don't worry too much about the dimensional analysis. I like to do that just as a throw-in. But 56.3. And I know it has to be meters because I'm looking for D. All right. So a reminder, just if things aren't making sense, I feel like I'm wheeling stuff around, to please just send me an email asking me to clarify something. And there's the 56.3. So this one you're going to do on your own. So I'm going to ask you to pause the video and do the work, and unpause it in a few minutes to get your answer. You should get 50.4. Now, how do you get this? Well, let's see what they give you. They give you 4.10 seconds, that's time. They give you the acceleration, 6.00 meters per second squared. So there's A, you have T and you have A. and you know the car is waiting for the light to turn green. So if it's at the light and the light's obviously red before it's green, that means VI is 0. So you want VI A T, and you're looking for D. So the formula that you want to use is the second formula on that slide. D equals VIT plus 1/2 AT squared. All right, so now we're going to move on to free fall. When an object is thrown straight up, it hits its peak when its velocity is 0 meters per second. That's the point where it stops and starts to come back down. When moving up or down, acceleration is 9.81 meters per second squared, and the sign depends on which way you're going. If you're going up, well, gravity always works down. That's what the 9.81 is. It's the acceleration of gravity. If gravity was working down and you're going up, well, the acceleration is going to be negative because it's opposite the motion. If you're going down, gravity is still acting down no matter which way you're going. So if you're going down, gravity goes down with you, it's positive now. So down positive, up negative for gravity. So these two you're going to try on your own. This is just a little background to help you up here. So please pause the video and do the work for those two, and unpause when you have your answer. For the first one, you should have 0.932 seconds. So here's your distance, 8.52 meters. And your acceleration is 9.81 meters per second squared. And the trick to this one is that it's saying it's dropped. If something's dropped, it starts with no velocity. Otherwise, if you're throwing something, well, you're putting a force behind it that adds velocity to it. Dropping means you start at 0. For the crystal vase, if it goes straight up, you should get 35 meters. So you're looking for distance on that one. You know initial velocity is 26.2. You know final velocity is going to be 0 for that one because that's the rule from up here. And you also know acceleration is 9.81, and that's negative 9.81 in this case. All right, so now we're going to move on to a little bit more difficult two-dimensional motion. You're going to be doing the same work. All right, the work is the same formulas. The only difference is that you're going to have to break some things into parts. You're going to have to treat X and Y independently. And I'm going to show you what that means. The only thing that ties the two X and Y together is time. The time that you're moving in the X direction equals the time that you're moving in the Y direction. Now, I'd like two-dimensional motion problems for the reason that acceleration in the X, that's what this AX here means, is typically 0. Now, why is that? Well, if I throw something, assuming that we're not going to count air resistance, once I throw it, what's the only thing acting on it? Well, the only thing acting on it is gravity. Does gravity work in the X? No. That's why we say only force acting on it will be gravity, which is in the Y. Peak height is reached at the half-time. Why is that? Well, again, that's where the velocity in the Y changes from positive to negative. And remember, that point, that's 0. Velocity in the Y direction at that point is 0. All right, so we're going to do this first one together. A ball is thrown with an initial velocity of 50 meters per second at an angle of 20 degrees above the horizontal. Determine its peak height and horizontal displacement if it took 3.49 seconds for it to reach the ground. So we're going to do this out, and I'm going to erase this. Now, as you notice, there are a couple things that are being asked here. The first thing is the peak height, and the second thing is the horizontal displacement. So we're going to start with the peak height. So let's just get the drawing in here. Here's the ball. Throwing it like that. Here's what its motion looks like. Here's my X. There's my Y. It says the angle's 20 degrees. That goes in here. And its velocity is 50 meters per second. Now, the more astute of you might have realized, oh, this looks like a right triangle almost. Well, it is a right triangle. So if I'm looking for the peak height here, here's my angle. I'm looking for this side. Here's my hypotenuse. Well, that's the opposite of that. I want sine for the y. So we're going to do the peak first. So the velocity in the y direction for the peak is 50 times sine 20. Now, I know it took 3.49 seconds for it to get from here up to here and down to the ground. Remember what we just talked about. At the half time, it's at its highest peak. So the time here is going to be half of 3.49, which is 3.49 divided by 2, 1.745 seconds. And since it's at the peak height, I know VF there has to be 0 meters per second. And since it's in the y direction, I know the acceleration is negative 9.81 meters per second squared. Why is it negative? Well, the ball at this point is going up, and gravity works down. All right, so I think I've got everything. I'm looking for y, which is my d. So let's see, I want d, a, vf, t, and vi. Well, there are a couple I could choose from here. I could do d equals vit plus 1/2 at squared, or I could do vf squared equals vi squared plus 2ad. Well, I'm going to stick with vit for this one, just because I have time. So d equals vit plus 1/2 at squared. I think my head might be getting in the way here, so I'm going to try to move over here. D is what I'm looking for. VI is 50, sine 20. T is 1.745 plus 1/2 negative 9.81 times 1.745 squared. And when you do all that out, you should get, for your peak time, just get it here, for your peak height, sorry, you should get about 14.9 meters. And let's double check that. I don't have my scientific calculator with me, so I have to use my phone here. And 50 sine 20 times 1.745 equals plus 0.5 times negative 9.81 times 1.745 squared equals 14.905, blah, 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 blah. So there you go, 14.9. All right, now for the horizontal. I'm going to erase this now, so if you need it, pause. For the horizontal, I know the VI in this case is going to be 50 times the cosine of 20, because now I'm traveling adjacent to that angle. And I know the time is 3.49. What else do I know? Well, I know that acceleration is going to be 0 because there's no force acting on it. I'm looking for the distance. And let's flip back to those formulas. And look there at D. At B, D equals VIT plus 1/2 AT squared. Now this is why I like two-dimensional physics. First of all, VF here is not going to be 0 because it is being acted on by that force, and it's not saying that it stops. You know, it could drill into the ground. So I can't use anything with VF unless VF is given to me. Now, if this is 0, this whole term goes away. So D equals VIT. Well, that's easy to do. In fact, we're going to do it now. Well, VI I know is 50 times cosine of 20. So 50 cos 20 times 3.49, I get about 164. 164 meters. And peak height 14.9, horizontal 164. Questions? Remember to please email me those. All right, you're going to do this one on your own, and then we're all set. Calculate the time it takes for a stone thrown at 25 meters per second at an angle of 40 degrees above the horizontal to hit the ground if it traveled 62.8 meters horizontally and its peak height was 13.2 meters. So you're attacking this one a little bit differently than the one I did, but all the work is going to be the same. So please pause the video and do the work, and I will hear from you in another couple minutes. Now, I think the easiest way to do this one is to actually do the peak height first, or the peak time, because to me, that's a quicker thing. And if you have peak time, then you have the total time. So the peak time is 1.64 seconds, and the total time is 3.27. Now remember, that's going to be roughly double that. All right, so this is going to be roughly double that. Just due to rounding and stuff, it's not exactly. So, again, if you have questions, please feel free to email me. The email address is going to be in the video description. I thank you for your time. I hope this helped. Have a good day.